So we have Dustin with us today, and I am very excited to see what he has to offer us. So there will be time for questions at the end. So there's going to be just kind of an overview of what he does and what you should be thinking about possibly in your shoes about how you could be the next person in Dustin's shoes.
If you want to be.
If
right?
you want
You
to
don't
be.
have to be. And I'll get to that too, right? So I brought my notes. I'll be reading my notes. No, I'm not going to read my notes. I met Chris through, his wife is somebody that I swim games with. And so once I learned that he was like teaching college computer science, it's like, heck yeah, let me go talk to some people, right? Captive audience. So today I'm going to tell you a little bit about myself, what I do. Not going to spend a whole lot of time on me, but then I'm going to give you a window, a peek into what it's like being a professional software developer. And then I hope to leave you with some ideas that you can take with you no matter what you're going to do. So starting with me, I'm a programmer. I've been coding for like 20 plus years. I started back in the 90s, back before Java and C# were a thing. I was a C++ developer back before smart pointers, all of that. And I got interested in programming because I love video games, right? I loved them as a kid and I wanted to make my own, and I knew a guy that knew how to code, and that he told me that's how you make video games. So I spent my middle school through high school years learning how to code. And by the time I finished high school, I realized coding's really hard, like really hard. And so I went to college, and instead of getting my degree in computer science, which was my intention, I had already signed up, I had already declared my major. And then I took my first psychology course and I switched immediately. So I actually have my degree in psychology, not in computer science, which makes it a really rocky road to become a professional software developer, right? And we could go into all kinds of stuff like that if we wanted to, but I'll leave that for later. So what do I do now? After all of the rocky road, I somehow made it to Microsoft. And I work within Xbox Game Studios, dream come true, right? I get to actually work with video games. Do I work on a specific game? No. There's a bunch of vertical teams. These are like your Forza, your Minecraft, your Halo. All of these are vertical teams. They make AAA games. And then there's horizontal teams that work across these different vertical teams. So I work on one of the horizontal teams. It's called Studios Quality. What we do is we help game testers test games, right? So our organization is not really interested in how do we make this game feel better or more fun or a lot of things like that. It's how do we find all those texture scenes? Can we get this game to crash? And we're trying to figure out ways of doing that more automated, faster, more reliability, more coverage using data and things like that. My role within that team is actually also really strange. I'm the only one on my one-person team. My goal is to shift left. What that means is you can have bugs that your users find. That's as far right as you can go, and that's the worst place to find them. They're expensive, and not only in cost to fix, but also losing trust of your players, right? If you gain a reputation for writing buggy stuff, that sucks. It is really expensive. So if we can push that to the left, hey, we've got a bunch of manual testers who are going around trying these things, right? How do you test Minecraft? It's an open world game that's procedurally generated. It's hard, right? So you just throw an army of testers at them. And 2 weeks before it's shipped, they say, hey, we found a crashing bug and you have to fix it. That's expensive. Let's shift further left. How do we get people to write automated tests, right? Write tests that at least use the game and see if they can get it to crash. And then shifting left even further, how do you get that written down in a way that the compiler can write your test for you? So sure, I can write a bunch of unit tests and end-to-end tests and integration tests and all things, even fuzz testing and property testing and all the other testing things that I know about, but you don't have to run them. And that's bizarre, right? And so you can just not run them and ship a game with a bunch of broken tests. It happens all the time. So I want to shift even further left. I want the compiler to be able to say, no, this is not valid, right? By definition, the compiler will just say, you said the type system needed to do this, and it doesn't, so you don't get a build. You can't skip that. And so pushing further left is into the compiler station. even further left is into like the design phase, right? How do we make it so that these bugs could never happen in the first place? So that's a really quick overview about me, and I have no clock to stare at, so I'm going to stare at my phone occasionally. Okay, so that's a little bit about me. I want to talk about interviewing, right? So y'all are learning how to code, that's awesome, right? And you might have a question like, okay, what should I expect in an interview, right? Because I think there's a lot of mythos around interviewing, like, oh, I'm going to need to know my algorithms and data structures, and they've got a pool of questions. And so I've been working professionally in the software industry for over a decade, 12, 13 years, something along those lines. And I've worked for multiple companies, and I've interviewed with multiple companies, not like been interviewed by multiple companies, but performed interviews for multiple companies, right? So I've interviewed dozens, if not 100 people. And I've been through the interview training for multiple companies, and it's all the same. They teach you, when you want to become an interviewer, they teach you ethics. Like, this is how we don't get sued. Good luck. Like, seriously, that's about all they cover. They give you some pointers about like, well, you know, whatever your hiring manager is looking for, maybe come up with a question or two and float it by some people, but they give you basically no direction on what it's like to come up with a good programming question, right? What is that going to tell you? And so when I'm doing an interview, I'm really trying to answer like 3 questions, right? I want to find the answer to these 3 questions, and I've got an hour to do it. First question that I want to know is, are you a programmer? Not like, are you an amazing person that can teach me, you know, underlying data structures of complex algorithms? I don't have time for that, right? I've got an hour. I need to use 10 minutes of that talking to you as an interviewee about what are you interested in? Tell me about your position, things like that. And then I need to spend roughly half of my time giving you some kind of coding exercise that answers the question, can you code? Right? I have definitely had interviews where the answer was a flat out no. They could not write hello world. And they should not have been interviewing, right? But that's essentially the baseline, right? It's just assumed that everyone can code. If you're trying to interview, if Microsoft is willing to put 4 hours or 5 hours of interview time, that's a lot of money into you as a potential candidate. We believe you can code. What I want to know is, can I work with you? And are you teachable? Right? Because no matter what your background is, no matter what jobs you've had, no matter what education you had, you by definition don't know anything about my product or my team or our process or the people that we work with. I have to teach you all of it. You're starting from the ground up. So yes, you have the basic tools of how to write code, but you don't know anything about this gigantic monolith that's 1 million lines of code that's been hacked together organically over a decade, right? So no matter what position I'm interviewing for, I still need to understand, can I work with you and are you teachable? And so a lot of times when I give questions, I ask questions that are intentionally ambiguous, and a lot of people do. The reason why is not to see like, oh, did you get all the trick questions? I'm not trying to trick you. What I want to know is, are you curious? Can you ask the questions like, oh, wait, is this a constraint? What if we do this thing? And we can have a conversation. I want to know, what can we do with this? And trying to keep my train of thought, but all right. So I want to show you the example of my actual interview question. Like, it's very unlikely that you'll be talking to me for an interview anytime soon, unless you happen to wander into Studios Quality. But I can show you my actual interview question. I have a few of them. This one is my general interview question. I've used it for contractors. I've used it for full-time employees, for juniors, for seniors. I've used it for all of them because it tells me what I need to know. So it's real simple. I have this written down at this point because I live in Spokane and Microsoft is over in Redmond. Almost all the interviews that I do are fully remote. And just a word of advice, if you are going to be doing a remote interview, or any of your interviewers are remote, even if not, just be prepared, like whatever device you're planning on interviewing on, have an IDE. Like, be ready to like set up a Hello World project in minutes, right? You should be able to start a project in whatever language you're comfortable with. I don't actually care, because if you can write readable code, it doesn't matter if I understand the language or not. So have something where within a few minutes, you can have Hello World like compiling and running, okay? Okay, so the problem is this, it's the collapse conjecture. And I'll do a little bit of shorthand because I can't, because my handwriting is terrible and I type much faster. So the collapse conjecture is a mathematical conjecture. It states that given any positive integer, you can apply the following two rules. If it is even, divide by 2. It is odd, multiply by 3, and add 1. And then I say, given an input, like 5, I want your output to be 5, 16, 8, 4, 2, 1. That's a series. And really, this is the problem. Like, it takes me just a couple of seconds to describe it. I give you the algorithm, right? You don't need to know any data structures. You don't need to know any algorithms. There's no market sweep or anything like that. It's really not that hard. And you'd be surprised by the mistakes that I get asking this question. Like, it's a fun coding exercise. The full answer you can write in basically any language in under 50 lines of code. And this is just part 1 of the question. But like, a lot of people will write something like this, like their output, I hope I'm still on screen, will be 5, 16, 8, 4, 2, 1. Not what I asked for. I gave you very particular output, right? I'm not asking if you can follow these directions. That's not that hard. What I'm asking is your attention to detail, right? Are you picking up on some of these things? After they get this one wrong, and I pointed out, they'll have something like 5, 16, 8, 4, 4, 2, 1, comma. Bummer, right? Or they'll forget the space, right? Like in the example that I give, there's spaces after each comma, and we'll drop them or something like that. It's minor little nitpicky attention to detail kind of problems, right? And so this shouldn't take more than a few minutes, right? I've got 30 minutes to work with you, and if you get stuck here, the answer is no. Like, if we can't get this output from that input with this tiny set of instructions, I mean, no matter what task I give to you, it's gonna be wrong. And so, so whatever your solution is for this, right? Like, I asked you to print out the collapse series, that's fine. My next question is, great, write a test for it. Right? I want you to write an automated test. I'm not saying you have to write the automated test framework, right? You don't need to even use any kind of frameworks. You can just have a test that returns a Google. Call it, I don't care. I just want to know, is your design, is your implementation testable? Like, oh, if you happen to just be printing these straight to the console, that's not testable, right? So how do I test an implementation like this? Well, I need to separate out my logic. That's going to tell me, can you refactor? Right? You have something that's working, but then I asked you to test it and you need to implement it in a different way, unless you're a TDD kind of person, which I have had people do that. And it's kind of impressive, but the majority of people write out some kind of implementation and then I ask them to test it and they need to start it over, right? They extract a new function, which returns like a list or vector of integers, and then they have the formatting function, which does it differently, and then they can add tests to the business logic itself, right? I'll also ask for, edge cases, right? What happens if I hand you 1? You print 1, 4, 2, 1, or is it just 1? Right? You could argue either one, but I would say that just 1 is probably fine. What happens if I hand you 0? right? 0 is even, divided by 2 is 0. You have an infinite loop. Did you even check for it, right? When it's wrong, how do you indicate that it's wrong? Do you indicate it through an exception? Do you indicate it through a message? Do you just return? Do you have an infinite loop? Like, there's a lot of different edge cases. And so even with a problem that's simple, you can still see that I can learn a lot about how you're thinking and how you're working by how you work through this problem. One of the often, so people fail on this in one of two different directions. Some people say nothing, right? They're completely silent. They type, hit run, looks like it works. And that was the entire conversation, which, sure, it works, it's fine, but we didn't talk at all. I don't know if I can work with you yet. I don't know if I like you yet. And, you know, maybe you're amazing and you can get it all right the first time, but I'm going to make this problem harder. The first way I'm going to make it harder is I'm going to say, well, this is just a conjecture. What happens if the conjecture is wrong, right? Wait, what do you mean? Like, this seems really easy. You just run through these two rules. Okay, but what happens if I find some number x, which goes to x2, x3, ... xn to x, right? Some number where suddenly I'm going around in a loop. I've got another infinite loop. How do you test for it? How do you check it? How do you know? And I've had some really bizarre answers. I've had somebody say, well, I would just make sure that the runtime isn't more than a minute. What? Who knows how big these numbers get, right? Like, that's not a great way to find out if the program will terminate. So, like Alan Turing and all of that Turing complete stuff, and you know, I forget what they call it. You can't tell if the program will terminate, but yeah, that's not a great way of determining if it's going to terminate or not. I've also had somebody say, well, if it overflows along, then it's probably not going to terminate. Okay, well, this conjecture has been proved up to 2 to the 60, so we're going to need some big integers if we want to go there. And people will ask, like, can we assume it all fits in a long? And I'll say, for this problem, yes, we can assume that's all going to fit into a long. But, you know, it's a good question to ask, right? Because I might say, no, you should have a big integer library. We want to actually test this, right? How do you test it? What happens if the numbers are so big they don't fit in memory? What? How do you do that? Throw it on a disk, right? Put it on a network. Some other way of storing things that isn't just in memory. So I asked you, like, how do you prevent an infinite loop? And this is my second question. It's already typed out because literally everybody just assumes that the conjecture is true, which is fine. I don't have a problem with it. I want to see, can you learn? I want to see when I pose this challenge to you, how do you respond to it? Like, oh, I thought it was just true. Okay, well, can you figure this part out? Or do I need to spell this out to you, right? That'll tell me the difference between a junior and a senior. A senior will say, oh, wait, I know. Or this while loop will never terminate if I ever see the same value twice. So I just need to make sure that I never see the same value twice. I'll throw a set in there. So I'll throw a set in that has all the numbers I've seen before. And every time I go through the while loop, if I see the number again, I break out. Perfectly valid answer. Actually, probably one of the best answers. And then my question comes back. Oh, how do you test that? What do you mean? Like, do you have an example number that goes on forever? No, if I did, I'd go get a Nobel Prize in math. Like, this is still a conjecture. It's not been proven. I don't have an example number that you can write a test with. How do you test it? Oh, well, I guess I can't just create the set inside the function anymore. I need to pass the set into the function. What happens if I have a set that has 8 in it, and then I run 5? I should get my error condition, right? It'll be 5, 16, 8. Oh, I've seen this number before. I fail out. I can test it, right? I can actually prove that the software works. So that's step 2. And most juniors make it somewhere around step 2. Seniors should be hitting step 2 in the first 20 minutes. And then I give them step 3, which is hard. Step 3 is, okay, let's assume that I'm running this in a production system for some reason, right? It doesn't make any real sense, but this is standing in for a real problem. How do I improve the runtime on it, right? Like these numbers, especially, so we did 5. 5 is a really short series. If we do something like 7, we get 7, 22, 11, 34, 17, on and on and on. Anything that's 1 less than a power of 2 tends to grow really, really big and then shrink down to 1. And so I'll ask, like, how do we improve this runtime, right? Like, let's say that I ran with 16 as my first number. I get 16,841. Then I run with 5. I shouldn't have to calculate 16,841 again. I've already figured it out. I could store the result of 16 somewhere and look it up later. So it doesn't make any sense for small numbers because the actual calculation will be faster than a lookup because you have to hash the number and all that other stuff and v tables and whatever. Anyways, but you could imagine for really large numbers, for sufficiently large numbers, it would actually make sense to take out thousands of calculations in exchange for 1 lookup, right? So do you know how to cache? And I've had a few people get through that part of the problem, and there's actually another part that makes it even more difficult. I said, if I hand you 16, right, and then I hand you 5, I should be able to see, oh, 5, I calculate that as 16. Oh, I have 16, I get the result. What happens if I flip them? What if I give you 5, 16,841, and then I give you 16? Did you cache the results, or do I have to calculate them again? 16 wasn't in that cache, but it could have been. And that's where it turns out that the optimal solution, which is not my first solution, right? I had to learn this from somebody actually solving it, is a recursive solution, right? You can actually write this recursively, and then you can actually get all of the numbers cached. So anyways, that was my actual programming problem. And, you know, we spend 30, 35 minutes working on it. And during that time, I'm watching, how comfortable are you with your IDE, right? Can you refactor? Can you rename things? Or are you just like up arrow, left, 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 left? Like, do you know how to navigate an IDE, right? Or do you know your keyboard shortcuts? Do you know how to compile? Are you moving around on the mouse? Are you lost, right? So I'm watching those kinds of things. I know what the solutions are. I can tell at a glance if the solutions, right? What I'm looking at is how do you work? How do you process? So that is a little bit about interviewing. How are we doing on time? I think we're doing pretty good on time. So I want to give you some perspectives. I'll leave this up here. So I want to tell you a story about a guy that I currently work with. We'll call him Bob because he's not named Bob. And Bob is a genius. Bob knows everything. He reads the release notes on every .NET release. He knows how, you know, C# is implemented down at the lowest levels. He knows how to optimize. He will find bugs. He goes the extra mile to find useful articles and sharing them with people. He goes out of his way to actually, like, when he's doing pull requests, he'll pull down the code and compile it and look for errors that weren't in the pull request, right? Like, oh, I found this while I was looking through your pull request. This guy sounds like he should be like up here, right? Like super senior. He should be way up here. I readily admit he knows more than I do. He's more careful than I am. And yet he's 5 levels below me, and he belongs there. Difference. Turns out it's just not just your technical excellence that makes you a good employee. It isn't. That's not enough. Every resume, every job posting you look at is going to say something about strong written and verbal communication skills. And this person fails at both of them. He lacks both written and verbal communication skills because he's essentially a cyborg. Like, really, like it comes across as condescending and nobody wants to work with him. He's a force multiplier of basically 0. Like he can work by himself and get a lot done, but as soon as he's working with someone else, nothing gets done anymore. So there is a concept that I was introduced to years ago called the grief index. The grief index is your productivity divided by how hard you are to work with. And the problem is the majority of people overestimate their grief index. They think they're really easy to work with. They think they're a pleasant person to just hang around with, and I'm super productive. My grief index is like way up here. Not like that guy, no, he's way down there, like I'm up here. Problem is we mostly overestimate our grief index. And that leads to a lot of people being surprised about where they are in their career. It actually leads me to be surprised where I'm at in my career because I underestimate my grief index. I assume that my numerator is super low, that like, there's people all around me who know way more than I do. I mean, I'm pleasant to work with, I'm chatty, people like me, and it turns out that denominator tends to be more important because while we all work in, well, while you're learning tech, right, while we're working in a very merit-based kind of field, you may think that your technical output is the primary factor, but the reality is we work with human beings, we work with people. It doesn't matter if you're in tech. It doesn't matter if you're in medicine or law or working at a gas station. At the end of the day, you're working with people. And if you can optimize for working with people, for making your grief index, your denominator as low as possible, be really easy to work with, you'll go a lot farther than only focusing on your technical excellence. Okay, related to that. So I mentioned that I got my degree in psychology, right? And that means I love pulling psychology into stuff because, hey, we're humans, behavior, right? So there is a couple of guys named Dunning and Kruger. Anyone know who they are? Got a few head nods, okay, we got some people. All right, I want to tell you this amazing story. Dunning and Kruger learned about this from like a newspaper or something like that. There was a guy who walked into a bank, broad daylight, and told the person at the register, give me all your money. Okay, they took all the money and handed it to him. Of course, they pressed a silent alarm, and he walked out. He was shocked, just flabbergasted, when the cops arrived at his door like an hour later. And it's like, well, he asked them, like, but I wore the juice. Which you could just feel the question marks like growing out of their heads, right? What are you talking about? We have you on camera right here. He had learned that you make invisible ink with lemon juice. And so he put lemon juice on his face, assuming it would render him invisible. Right? You can't make this stuff up. And Dunning and Kruger learned about this and came up with a theory. The theory is that, okay, I will erase some of this. I'll leave the important parts on there. All right, there is a graph. And on this graph, there's experience and confidence.
Oh yeah, I think I remember this now.
Yeah,
I've
okay.
heard of it before.
Yes. So the problem is that the graph looks like this. It looks like a mu or something like that, right? Basically, I've heard this called Mount Stupid. Right? Knowing enough to be dangerous. There are a lot of people who know this much and believe they're right up here. And it's related to that grief index as well. And as you learn more and more and more, as your experience grows, you become humbled. You realize there's way more than you could ever learn. Everyone around you knows something that you don't know. And I would be willing to bet money that every person in here knows something that I don't. You all have knowledge that I don't have, right? But at the same time, I know things that you don't know. And so what happens over time is you get humbled down into this valley. Now, I actually disagree with this graph, but only slightly. I believe the graph looks like this. And that's the problem. The problem is that once you get out here, as your experience grows further and further and further, you run into imposter syndrome. Imposter syndrome is where you realize that I've been doing this for a decade, and I talked to somebody who's fresh out of college and they knew something that I don't, right? That can be really humbling. And you start wondering, like, am I providing value? What you don't realize is that your experience is growing every time you solve a problem. But it leads people to burnout. It leads people to to quitting, to switching jobs, right? Like I've been tempted on multiple occasions to say, I shouldn't be a principal engineer, maybe a senior, maybe a low-level senior. My management doesn't think so. I got promoted last year. Why? I don't know. I'm down here. Right? And so wherever you think you are, like look at this graph and help that determine your grief index. So I've been talking for half an hour, just over half an hour. I want to give people time for questions. I'm here as a panel. If you need me to come up with some other cool things to talk about, if there's no questions, I'll come up with something. I've got some backup ideas. But like, I'm here for you guys, right? Like I came here because I believe in education. Even the education that I didn't get because I skipped it for psychology instead. And I believe that, well, I want to equip as many people for the field. If you're going to become a software developer instead of a computer scientist, those are different things. If you want to go in that route, then I want to invest in you early so that you learn from my mistakes, so that you learn from the mistakes of the other people on my team, right? Bob, who's been there a decade, knows way more than I do. And he's, you know, I don't think he's even a senior yet. I think he's an SC2. Don't be Bob. So with that, I open the floor to questions. Yes.
How do you see, this is kind of off topic, how do you see psychology being, like, not through like communication skills or anything like that, but like things in psychology, like did it?
So I think that psychology is relevant to anything that has humans in it. And we have a lot of humans, right? I think that psychology is going to become a lot more applicable when it comes to AI. How do we write an AI that people trust? How do we write an AI that isn't condescending, that is picking up on intention, on mood? And so natural language processing, NLP, takes psychology into account. And so I think as we improve on our user interfaces, especially as AI becomes more and more ubiquitous across all of our interfaces, I think that psychology is going to play a major role, at least from a customer standpoint. From like inside the tech field, I think that your best managers and your best employees will have an understanding of human behavior. When you realize that you're working with humans, your behavior changes, right? It's no longer like, no, I proved that it's right. Stop talking to me, right? It's, oh, I can see why that is confusing. How can I make this more clear, right? Like, take the human element into everything that you do at work. It doesn't matter if you stay in tech. Again, like we're working with humans. Humans are the ones that are hiring you. Humans are the ones that are paying you. If you want to have a job, if you want to gain a job through an interview and keep a job and promote yourself, get promoted in a job, realize that the human element is more important. Like, as somebody who loves tech, humans are more important. And you remind me of another thing I was going to put in there. So yes, it is my last note there. Here. There are a lot of people, I have talked to a lot of people that learned that I love to code. And I tend to be really passionate about telling people about code. And they're like, great, I want to try it. And then they try it for like a week and they get burned out and they hate it. And people tend to do one of two things from there. Either they give up, or they like try and power through and just suffer through coding because it's a lucrative job, I guess, or something. I've worked with a lot of people that don't want to be there, that don't like code, that they're there for the money. And that's not good for humans, right? My point is, find what you love. There's a lot of things in tech that aren't code. You could be a project manager. You could be a team lead. You could be a manager. You could be an artist, a tech artist, right? You could be a content creator of all sorts of kinds of things. You could be an architect. There's a lot of things that don't actually involve code in tech that are plenty lucrative. But what you have to find is find what you love, find your passion. The money will come later. And when I do career jams, we do career jams twice a year where a bunch of people come ask me career advice, and I have very little other than do what you love and the rest will come later, right? Like, stop trying to game the system. Stop trying to like, I'm gonna put a big plan in place where we're going to hit these 5 points, and you're working with humans, man. That's not how it works. Just find what you love. Do something that you're passionate about. You'll get better at it because you're passionate about it, because it keeps your interest. I go watch coding videos almost every day, right? I go and try and find something fun and interesting because I love code. So I happen to be passionate about coding, which has served me very well. Not everybody is. So regardless of whether you stay in tech or stay in, computer science or academia, or if you go and do something else entirely, just find that passion and lean into that. The money will come later. Okay, sorry. I think you had it.
Yeah, so more focused on when you're actually interviewing
Yeah.
someone. I've heard most of the time when you are interviewing someone who's fresh out of college, maybe hasn't had one.
Mhm.
It is more important in a program to be able to explain what they're doing, have like a cohesive line of thought as to what they're doing, and explain that out loud to you while they're solving the problem.
Mhm.
Is that something you really look for? Is that something that you don't see very often, or
Yeah.
what are kind of the social cues within that are important?
For sure. It is definitely important for me to understand whether somebody knows what they're doing, right? And again, there are people who are super silent and say nothing, and there are people who blab the whole time and get nothing done. You have to be in between those two goal points, right? Like somewhere in between where you say, okay, yeah, I think I get this problem. So is it an actual requirement that it's on a single line? Yes. Okay, so I'll use print instead of print line, right? Okay. Is that space between commas, after the comma import? Yes. Oh, great. Okay. So asking questions like, okay, well, I remember you saying that you needed this to be in this particular format. So I'm going to set it up. I want to use the abstraction where I have a list of numbers and then I'm going to print them out. And I could ask, oh, what are the pros and cons of that? Well, the pro is that I can format it later. I can change the formatting without doing whatever, and it's really easy to test. Okay, what are the cons? Well, I need to store all the numbers in memory. Okay, great. I'm glad that you know that. That can be a discussion, right? And so I will poke and prod and see, are you thinking or are you being mechanical? Because again, we're working with people. And so I want to know, like, what is your thought process? And if you're super quiet, and I have another problem that I give to people, I actually just hand them my Rubik's Cube and just say, program this. And like, that is a really ambiguous problem, right? And it's one where we have to talk a whole lot. There's not enough time for you to solve it unless you've tried it before, and even then it's hard. So I end up working with somebody, right? I'm on the board too, doing the whiteboard thing. What's the coordinate here, right? Like, oh, what if we break the cube into cubies and each one has a position, orientation, rotation, all of it. Like, I want to see, can I work with you, right? I have another problem where I teach the sieve of Eratosthenes. That's my algorithms question, right? I'm going to explain an algorithm I want you to implement. Then you can ask questions to understand. And then I have another question with data structures, where I teach people about bit sets. If you don't know about bit sets, they're amazing. Anyways, and so what I'm doing is I'm teaching, right? My goal is to teach them something I bet they don't know and see if they can pick it up, see if they learn it, see if they grok it, see if it makes sense, right? So yes, I'm always looking for some kind of communication, right? I'm not telepathic. I can read your code. That's not what I'm looking for. I know if the code is right or wrong as soon as you write it, because I've given the problem to 20 people before you. What I need to know is you. Yes.
Yeah, I actually have two individual questions, but they should be very short to answer.
Okay.
Yeah, what my first question is I hear, and it's kind of true for the past decade, that the kind of software development market for jobs is kind of oversaturated and very competitive. I was wondering if you had any advice for like what branch of software development the student who's interested in this type of stuff should probably more focus into with better job availability.
Mhm.
My second question, is there any advice on your part for trying to get out of tutorial hell? Kind of the concept of where like you keep like all your stuff is contained in classes for all your coding, but you don't have a lot of presentable projects on your own part outside of school, kind of show to an employer of like what you've been, like what your skill set is.
So to the first question about like what part of tech is going to be the most, the easiest to get into, I guess is kind of how I interpret the question. I'll go back to a previous answer, which is do what you love, right? It doesn't matter if all the money happens to be in Azure. If you hate working on distributed systems, you're just going to hate your life. You're not going to excel. You're not going to make any headway. I worked in Azure for 2 years, right? And then I moved to games. Because, I mean, I've worked with distributed systems for a long time. I've designed them, I've implemented them. But like, that's not where my passion is. My passion is in like low-level C++ code. I want performance. I want, you know, things that, I want the compiler to prove that this thing is right and not depend on running unit tests. So like, if you're looking for like career growth opportunities, sure, like go where the money is. That means Azure and AI right now, right? That'll change at some point. I don't know when. Maybe it won't, and AI will just take all our jobs. I don't know. And so in terms of the job market, yes, it has been oversaturated. There's a whole bunch of people that are like, I know HTML and CSS, hire me. I don't need HTML, CSS. I need somebody who can write a system. Actually, this reminds me of another point. By and large, I don't need you to be able to write a system. I need you to be able to read a system. I'm not building a new product. I've got a product that's been going on for 5 years and I need somebody else to maintain it. And it's got 5 years of legacy code in there. Can you read it? Can you understand it? Can you change it safely? Can you write tests around it, right? So being able to interpret somebody else's code is oftentimes more important than being able to design a new system, because they're going to give the new system design to some higher up person, right? They're going to give that to somebody who's like designed a bunch of systems. They know all the pain points and all the failure points. It's like, we're going to design simplicity into the system from the ground up. You don't understand why, but this is simple, right? So yeah, being able to read code tends to be a more important skill than being able to write it. Then in terms of like getting out of tutorial hell, I would say, well, I'll offer confession. When I read people are interviewing, right? People want a job. I'm a technical interviewer, which means you've made it past HR. I have no idea what HR is looking for, other than they love to see degrees. They love to see, well, past work history. I don't know if they even look at GitHub repositories or not. I don't know. I don't, right? I don't actually care what is in your GitHub repository, because I don't know that you wrote it. I don't know if you stole it from someone else. I don't know how long it took you. I could potentially go read it, but I give you an hour. You have 1 hour to prove to me that I should put you on the team. And regardless of what your resume says, regardless of what your GitHub profile says, if I can't tell that you should be on the team in an hour, you shouldn't be on the team. So that's all the time I give you. If I get 40 candidates, I can't go look through 40 Git repos. I just don't have time. And so, yeah, that's my brutally honest answer to like, how do you create a portfolio that will catch somebody's attention? I don't know that it will. But that doesn't mean you shouldn't have a GitHub portfolio. I have a GitHub project with all of the Advent of Code problems. If you've not seen Advent of Code, it's coming up again in December. 25 problems a year, and they're amazing. So there's an idea called programming katas. A kata is where the thing that you're producing isn't important. What matters is the way you produce it. So you can imagine FizzBuzz. FizzBuzz is not an important project, but learning how to write FizzBuzz using TDD, like pure TDD. Now that's practicing a skill. Or learning to write it without the mouse. What? Yeah, or learning to port it to a new programming language. How do you write it in Rust? How do you write it in C++? How do you write it in F#? Right? I want to write this functionally. So you work on the same problem over and over and over again. You know the problem. What you're practicing is the skill of development, not the end product. And so I use Advent of Code as a way of sharpening my C++ skills. I gave myself a constraint last year, which was everything, 1, had to be written in C++, and 2, everything had to be a constant expression. If you don't know what C++ constant expressions are, they're amazing. You should look at them. But that was my constraint. That was my kata. It's like, I want to learn how to write everything in a way that does not invoke undefined behavior in C++. That meant I needed to learn how to write data structures. There's not a data structure in C++ that allows you, there's no map that is context for in C++. I had to write one. There's no stack or queue. There's a vector, so I built everything on vector. And yeah, so I learned a whole bunch doing that. And then like watching videos and watching people do cool things, reading things and all of that. So go practice, definitely practice. And keep a library of all the things that you've solved before. I steal from that project regularly. In like regular work environments, I will take like, oh wait, I know how to write a constant expression square root. It's right here. Here you go. Right? I've solved it once before. I can just copy and paste it from myself. So hopefully that answers the questions.
Yes.
Kind of also have two questions. One of them is that if people to like, put your like LinkedIn up or even like your GitHub, fine.
Oh,
All of those questions.
So I'm not on LinkedIn or any social media, but my handle basically everywhere is it's Dustbuster with all the vowels removed. I've had it since I was 13.
It's the only way it happens.
Yeah, so that's my GitHub handle. You can find my GitHub repo. It's got all of my core CPP library stuff. It's got all of my advent of code stuff, and I had a weird idea that I'd go make an Android game, so it's in there too. So, and it's all built in C++. I didn't want to use a library. I didn't want to write it in Unity. I didn't want to write it in Unreal. Even though I work with people who work in Unreal and work in Unity, I wanted to write my own engine because that's where my passion's at. Is down at the lowest level. I'm not a content creator. I love creating systems.
And how did you find yourself going back to tech after graduating in
Yes.
psychology?
Yes, we skimmed over some of that. Okay, so I got my degree in psychology. It was an undergrad, it was a BA, it wasn't even a BS in psychology. And then I realized really quickly that unless you have a master's degree, there are no jobs in psychology. Bummer. So I went and worked for a law firm doing finance. Right? And as one does, and that was fine, right? It was a job, it kept me employed, but I wasn't really happy with it. And I probably would have just suffered through it for too long until the company went under. Like we knew a few months in advance, like they were going to get acquired. Like they started dropping out all the benefits, like paid parking. Oh no, we can't do that anymore. Like they just started dropping benefits. That was a canary in the coal mine that told me they're not going to be around much longer. So I started studying in my nights and weekends. And just had my Code Complete book, I had my Pragmatic Programmer book, I had a refactoring book, design patterns, a gang of four. I just started reading and started coding, right? I took my project from high school and it's like, I wonder if I can get this to compile. And, you know, I started teaching myself all of the fundamentals of like software, right? Software development. I didn't learn any computer science. I couldn't have told you what a dictionary was, or a set was, or a vector, or any of those things. I knew them to the degree that I had to use them, and that was it. And I met somebody through my church, actually, that was running a company. This was in the Midwest. This was in Indiana. Like, if you think Spokane is lacking in tech, Indiana had none, especially 13, 14 years ago. And he was running a little Java web shop. It's like, sure, like, if you're offering me a job, I'll go try it. And that's what got me started. I worked there for 3.5 years. And then it's like, well, we want to move back to Washington because my wife's family all lives in Washington. So I started applying for jobs. Like, okay, I got 3.5 years of experience. I should be pretty good. I was still up here, right? I should be pretty good. I know what most of these people know. No, my resume didn't look good at all. And we'll talk about resumes in a second if we have time. I ended up working for a contracting company. I was a contractor for eBay. And they hired me for, you know, eBay brought me in as a contractor and I worked there for 6 months. And because I focused on like the human element, they converted me from a contractor to a full-time employee after 6 months. Like halfway through my contract, they're like, why isn't this person working for us? They realized that I had the skill and that I was a reasonable human being. Like I wasn't contractor material. I just didn't have a resume that would make it past HR. And then the next job was somebody who poached me out of eBay. Like, hey, I switched over to Microsoft. You wanna work for my team? I sure do. Submit a resume, instant rejection. And then he's like, yeah, don't worry about that. We'll get you in. And I interviewed and got a job. So yeah, my resume does not look like your resumes are all going to look much better than mine. Mine says I have a BA in psychology and I've been doing this for 12 years. And point on resumes. I don't know what the standard is in academia. I've heard horror stories in the field. Like if you're working in software, you get 1 page. Like you don't get 20 words afterwards. You get 1 page. If you can't summarize your experience or knowledge in 1 page, then I'm not like I will stop reading. My resume is 1 page. Despite working for multiple companies on multiple projects over a decade, I have a 1-page resume. My education says Western Washington University Psychology BA. That's all it has on it, right? Everything else is all my work experience, but I still condense it all into 1 page. And every time that I put my resume together, I shrink all the old stuff and emphasize the new stuff. Right, it's like, oh, I have to condense this into like, hey, I was working for this company and doing cool stuff, you know, Java web development and distributed systems. But now I'm working on this other stuff.
To wrap it up, we are
Okay, yep.
out of time. If you have a few more minutes, maybe you could, some students with some questions could.
Yeah, for sure. I'm good for however long you would like me. I don't think I have any other issues.
And my plan, I have to run this by. Yeah, but I'd like to see anyone come back for my game dev sequence, for anyone who is planning to take that, to talk more about the actual games side of what it does. Yeah.
What
Please.
course number is that?
That'll be 4:30. We got a course number in the future, but we're running it as a
I'm taking
topics course for now.
engineering.
Let's take a moment to thank Justin for his time.
Yeah.